Unit 4, this is according to the new specification. I'll discuss both MCQs and the structure questions. So in this question, bromine is oxidized methanoic acid to carbon dioxide. The equation is shown. Which of the following method would not be suitable to measure the progress of reaction? Colorimeter can be used. Why it can be used? Because aqueous bromine is colored, and when it changes to bromide ion, it will change it will be colorless. So the intensity of the color or the color will change. Measuring the electrical conductivity can also be done. Why? Because reactant side you don't have ions, and as a product there are ions, so electrical conductivity will also change. Quenching and titrating with acid. So you have to check, because if you quench with acid means there should be a either a reactant or a product which should react with the acid. So methanoic acid, you don't find a reaction of methanoic acid with another acid. Bromine is there, no reaction, and same thing carbon dioxide, bromide ion or hydrogen ion. So neither reactant or product are reacting with acid. So this method cannot be used. Measuring a volume of a gas can be used. Why? Because when the gas is given off, so we can measure the volume of gas. Is it clear why C is the right answer for the first one? Then in this question, the rate of the reaction between the two compound X and Y. So there are two compound, one is X, another one is Y. So they are reacting with each other. We have to determine the order with respect to Y and order with respect to Z. So first thing, uh, for Y we did not change. Experiment 1 and 2, what we did, we double the concentration. As we double the concentration, what happened to the rate? It become 4 times. So it means rate is proportional to concentration square. That's why if we double the concentration, when the concentration is doubled, the rate is 4 times. So it means it is second order with respect to Z. And what about Y? When you compare experiment 2 with experiment 3, so experiment we keep zero point 0.4 rate concentration, the rate was 3.2, but what we did, this will become half. So if this is divided by 2, but for a rate it does not change or no change, so it means the change in concentration is not affecting the rate. So what it shows? It shows that it is zero order with respect to Y and second order with respect to Z. If any question you want me to repeat, I will repeat. Otherwise, I'll move on to the next question. So inorganic anti-cancer drug cisplatin PT, and the formula is hydrolyzed by water to make an active. It's hydrolyzed by the water to make it active. The reaction is shown. The hydrolysis is a first order overall. Means if you double the concentration, rate will be double. If you triple the concentration, rate will be triple. And half-life for first order reaction, it is constant. So half-life can be found from the graph. So cisplatin concentration is there against the time, uh, the half-life of the reaction. So how to work the half-life? Like originally, if you take the first value, it is 20, then half of 20 is equals to 10. So what you have to do, you have to draw a line from 10 and work out the time interval. Each box is representing 20, because from 0 to 200 there are 10 boxes, so each box is representing 20. So when the concentration changes from 20 to 10, so it is 3 boxes. If each box is representing 20, so 3 boxes will be 60, so this will be 460 minutes. So half a life of this reaction will be 460 minutes. And it's a first order reaction. So first order reaction, you can take any value. It's not necessary I should take 20. I can take like example 16, then half of 16 will be 8. And I will work out like what is a time interval when it was 16, and same way the time interval when it changes to 8. Propanol react with iodine in acidic solution. The rate equation for the formation of iodopropane is found to be, so you can see the rate of the reaction involve the substance which are involved in the rate determining step. So hydrogen ion is there and propanol is there. Which of the following is true? So when you check the options, the unit of the rate constant, this is a rate constant K, it is mole cube, sorry, dm cube, mole inverse and second inverse. How you can work out? Because what is the unit of rate? Like it's a change in concentration divided by time. So what is the unit of the concentration? Unit of the concentration is mole per dm cube divided by time. Time is in seconds. And we are finding the K, the unit for K. Unit of concentration is mole per dm cube. Then also mole per dm cube. So 1 of mole per dm cube cancel with mole per dm cube. So this dm cube is divided, other side it will be multiplied. So it will be dm cube in numerator, second is in denominator, and mole is multiplied, other side it will divide. So when you make like move all of them in numerator, so this power is 1, mole power is 1, so it will turn into dm cube second inverse mole inverse. The second one, which of the following? So for this one, as we check the statement, first statement is true. That's why we did not check the overall. And the which of the following is not true? Or which of the following is not correct? The reaction rate increases with the temperature. That's true. The rate constant increases if the temperature increase. That's also true, because what happened when we increase the temperature, the value of rate constant increases. That's why the rate is also increased. Addition of small amount of sodium hydroxide decrease the rate. That's true, because when you add sodium hydroxide, that sodium hydroxide, what will happen? It will react with hydrogen ion. So it reduces the amount of hydrogen ion. So if we decrease the amount of hydrogen ion, the rate will also decrease. The rate is unchanged when hydrogen ion concentration double. It depends on the hydrogen ion. So if you double the concentration of hydrogen ion, what happened to the rate? The rate will also be double. So statement D is not true. In this question, the equation shows a hydrolysis of 2-bromo alkane. The rate of the reaction, you can see the rate of the reaction only depend on the presence of the halogen alkane. So it means it should be a tertiary halogen alkane. Why it should be tertiary? Because when tertiary halogen alkanes are there, there's a steric hindrance, like the attacking nucleophile does not find space to attack on the carbon, the central carbon, which is surrounded by alkyl groups. So due to steric hindrance, the OH, the nucleophile, cannot attack on this partial positive carbon. So first the bond breaking should happen and then OH will attack. That's why the rate only involve the halogen alkane, not the OH group. So which of them is a tertiary? So you have to draw the structure. If I draw the structure of 2-bromo 2-methyl propane, yeah, so D is the right answer, because when I draw the structure of 2-bromo 2-methyl propane, so I select the longest chain. So this is a carbon surrounded by 3 alkyl groups. So OH does not find a space. That's why D is the right answer. The equation for an exothermic reaction is shown. Which of these is true? Those who want to answer can use the chat to mention the answer. It's like for practice also, as well as I will discuss these questions, even though you answer, but I'll discuss so that you can understand or have a better understanding of the topic. So reaction is exothermic. If reaction is exothermic, the delta H cannot be positive. That's wrong. Enthalpy of the surrounding is positive. That's true. Why? Because enthalpy of a surrounding is minus delta H by T. And if a reaction is exothermic, so enthalpy change is negative. If enthalpy change is negative, so the final answer will always be positive. So enthalpy of a surrounding is positive. That's why. Enthalpy of system is negative. It cannot be, because you can see a solid and aqueous, and here aqueous and gas. So more greater random motion as well as greater probability on many ways for the arrangement of the particle. That's why the entropy should be positive, not negative. The total entropy is negative. Why total entropy cannot be negative? Because entropy of the surrounding is positive and the entropy of the system is also positive. So the final should also be positive. That's why which statement is true? B is a true statement. In question 7, the equation for equilibrium for decomposition of hydrogen iodide into hydrogen and iodine can be written in two ways. One is known as Kc, another one is Kc dash. So what is the expression for two equilibrium constants? So what we will do, we will just simply relate them by using a mathematical equation. Because if I write Kc for this, Kc is a product divided by reactant. So concentration of hydrogen, concentration of iodine divided by hydrogen iodide raised to power 2. And when I write Kc dash, that is square root or power 1 by 2, you can say, like hydrogen ion concentration raised to power 1 by 2, iodine concentration raised to power 1 by 2, and divided by hydrogen iodide. So you can see if I square this equation, square both sides, so the square and the root will cancel. This will become Kc dash square is equals to, because the square will be there on hydrogen also and iodine also, that cancel with half. So this will become concentration of hydrogen, concentration of iodine divided by hydrogen iodide square. And what is hydrogen iodide square? Hydrogen ion concentration, iodine ion concentration divided by hydrogen iodide concentration square, that's equal to Kc. So I can say Kc dash square is actually equal to Kc. So which statement it matches with? With statement A, it matches. That's why A is the right answer. A buffered solution is there which contain ethanoic acid with a concentration of 0.1 mole per dm cube. Sodium ethanoate is there with a concentration of 0.05. Dissociation constant of ethanoic acid is given. What is the pH of the buffer? So how we work out the pH of the buffer? So if you have a ethanoic acid, basically the salt also provide the ion. So we have CH3COOH. It dissociate into CH3COO and H positive. There is a direct formula also to find the concentration and which relate the pH of a buffer solution, but I'm using a detailed method. So because it's a weak acid, so what is our assumption? Our assumption is the concentration of the acid, like there's negligible or no dissociation. So the original concentration of the acid remains same, like it was given 0.1. So the concentration of the acid remains 0.1. And from where we get this acetate ion or ethanoate ion? It's from the salt like sodium ethanoate. As we have sodium ethanoate, CH3COONA, it will dissociate into CH3COO and N. So basically, because it will dissociate, the concentration of CH3CONA is same as concentration of CH3CO. So both will have the same concentrations. So this will be 0.05. And what about hydrogen ion? Because we can say it is unknown, we don't know. So hydrogen ion concentration. So when I write the expression for Ka, dissociation constant, which is for acids, it's a product divided by reactant, so CH3COO plus H plus and divided by concentration of acid. I need hydrogen ion concentration, so Ka multiplied by concentration of acid divided by concentration of ion CH3CO. I'll get hydrogen ion. And just substitute the value. K is given. The concentration of acid is also there. Concentration of salt is there. You can find hydrogen ion concentration. After finding hydrogen ion concentration, you can use pH is equals to minus log of hydrogen ion concentration. So what will be the answer when you substitute the values? 4.47. That's B is the right answer. Uh, the graph shows the change in pH during the series of titration. Each titration involved two solutions of each of concentration 0.1. Which graph has ethanoic acid as one of the reactant? Ethanoic acid is a weak acid, so means the pH should be greater than or equal to 3. So if we check the values, like this is even it's 1, so it's strong. This also even less 1, around 1, it's also strong acid. Means it shows that this titration involves strong acid. So this also 1, but for this one it's about between 2 and 3, 2 and 4, which is about 3. So D is a right answer. Like from ethanoic acid you conclude that it is a weak acid. So if it's a weak acid, it means the pH should level around 3 or more than that. Which graph shows a solution that has acidic pH at the end point? Basically, look, if you have strong acid and strong base, so if you have a strong acid reacting with a strong base, it means the solution and like the end point will show, or the equivalence point, when all of the acid reacted with an alkali or they are in the same ratio, so equivalence point will be neutral. But if you have weak acid and strong base, so equivalence point, if there is a weak acid and strong base, so equivalence point will be around, like it will be alkaline solution. If you have a strong acid and weak base, equivalence point will be acidic. So in the question, we have to show which graph shows a solution that has acidic pH at the end point. So you can see this graph is there. Acidic pH at the end point. Because what you can conclude from this one, strong acid is reacting with strong base. Here also strong base is reacting with strong acid. Here weak base is reacting with weak acid. It's 13. Strong acid, strong base is reacting with weak acid. But in this one, it is strong acid is reacting with weak base. So which one of them you will have an acidic solution because strong acid is there. So for graph C or third graph, you will have a pH, acidic pH. Is it clear why? Because the type of the reaction, when you have a strong acid, like example, hydrochloric acid is there, reacted with say aqueous ammonia or ammonium hydroxide. This will result in a formation of ammonium chloride plus water. But what is this? Because this ammonium ion is there. No, it's not about the slope is acidic. You even for graph 4, it is also acidic. You can see for this part also acidic. What is the meaning of endpoint? Endpoint means the region where the indicators show a color change. That is known as the endpoint. This is the part where the reaction, all of the alkali is used up. So it's not about at the endpoint does not mean at the end what is the pH. Endpoint means when all of the acid neutralize the alkali and indicator will show a color change. That is known as the endpoint. And the endpoint or equivalence point, how you can identify that? You can identify by the nature of the reactant. As at this point, it's a strong acid is reacting with a weak base. So because weak base, if something is a weak base, it means the conjugate acid which is formed by that weak base will be stronger. Like example, if say ammonium hydroxide was there, it dissociate into ammonium ion and hydroxide ion. So for weak alkali, its conjugate acid will be stronger. So already strong acid and the conjugate acid which is formed is also stronger. That is why the solution will have a pH less than 7 at the end point. So just an easy way to recognize this: strong acid, strong base. So equivalence point will be at 7. Strong base react with strong acid. Again, equivalence point will be 7. Here, strong acid react with weak base, so equivalence point will be in acidic side. Like the solution, when the acid is completely neutralizing an alkali, that moment, because the conjugate acid which is formed by the weak base, that will make the solution acidic. And here, strong acid react with weak base, strong base reacting with weak acid. So what will happen? The solution again here, the solution is also alkaline because for weak acid, its conjugate base will be stronger. That's why when all of the weak acid is used up, we are left with conjugate base, and conjugate base is stronger for a weak acid. So this will make the solution alkaline. Is it clear, this part B? Identifying the pH of the solution at the end point. Equivalence point means when all of the acid, equivalence point means we can identify the equivalence point from the vertical part, but definition of equivalence point means that when mole ratio, like according to the like for every reaction there's an equation, when mole ratio and volume ratios are equal, that point is known as the equivalence point. So in a vertical region, we can identify, but the definition of equivalence point when the mole ratio according to equation is equals to volume ratio. Then which indicator is suitable for titration in graph 3? So first thing, what is graph 3? Graph 3 is for strong acid reacting with weak base. So you have to check the vertical part. And after checking this vertical part, what you have to do, you have to check the range of each indicator using a data booklet. So this is a data booklet. Using a data booklet, we have to check the range. So bromosol green, the range is from 3.8 to 5.4. So this one is 3.8 to 5.4. Bromothymol blue. Bromothymol blue, the range is 6 to 7.6. Phenol red. Phenol red, the range is from 6.8 to 8.4. Thymol blue acid. Thymol blue acid 1.2 to 2.8. So these are the ranges for these acids. Now what we have to do, we have to work out like which one is in the vertical portion for graph 3. So we have all these ranges. So this vertical part, which one it matches with? When you check for B does not, it matches with A because like from 3.8 to 5.4, that will lie in a vertical. So A is a suitable. 6 to 7.6 is there, but 7.6 is not there. So it cannot use 6.8 to 8.4, that's out of range. And then 1.2 to 2.8, that's also out of the range. That's why A was the right answer for this one. So using a data booklet, you have to work out. Then which diagram shows the first step mechanism of nucleophilic addition of hydrogen cyanide to propanol? So carbon should be partial positive. The electron, the lone pair, should attracted towards the carbon positive the side, and oxygen should take both of the electrons like which are involved in the bonding. That's why oxygen will get a negative charge. So for question number 10, the correct figure, the representation A is the right answer. You have to check one by one, but when you check for others, you'd find that for this one, the direction of arrow is from carbon partial positive to nitrile group. That's wrong. Here carbon is given partial negative. That's wrong as well. Again, the direction of the arrow is wrong. It's from partial positive to the nitrile group. Propanone react with iodine in the presence of sodium hydroxide. The precipitate, the yellow precipitate form. This is also known as triiodomethane reaction. So triiodomethane reaction, what is the product form? It is triiodomethane. So CH and I3 is there, which give a yellow precipitate. This is the thing which give a yellow precipitate. Which of the following could not be formed when methylamine is added to ethanyl chloride? So when methylamine, basically methylamine means CH3 NH2 reacted with ethanyl chloride, CH3 C double bonded with O and Cl. So what happened? The hydrogen is replaced by, because this is partial negative positive, and when for this group, because NH2 is there, So in this one, NH is partial negative and one of the hydrogen is partial positive. So negative will replace the negative or positive will replace positive. So it will form CH3 NH C double bonded with O, CH3 plus HCl. And this HCl is which is formed can also react with amine. Amine is basically alkaline, so it is a proton acceptor. So it will be CH3 NH2 may react with HCl, and this will like acid base reaction. So this will form CH3 NH3 positive and Cl negative. So this one is there, and CH3 C double bonded with O, and this is also there. HCl is there. Which of them is not formed is CH3 C double bonded with O. So ethanamide is not formed. Basically, ethanamide is formed when ammonia is reacting with ethanyl chloride, or ammonia directly react with CH3 C double bonded with O and Cl. Is it clear why the C is not the possible answer? Because it cannot formed here when amine reacted with ethanyl chloride, like methylamine reacted with ethanyl chloride. So partial negative replace partial negative. So it will be CH3 NHC double bonded with O and CH3. That's form an amide. Plus HCl will be there. And HCl is an acid, can react with another molecule of methylamine, result in a formation of a salt. So these three products are possible. The one which is not possible is ethanamide, because ethanamide is formed when acyl chloride or ethanyl chloride reacted with amine group, ammonia, not amine. In which of these ester is a percentage by mass is 54.5%? So first thing, when we have to check, basically we have to calculate this. So if you want to calculate methyl ethanoate or ethyl methanoate, cannot be an answer because they will have the same number of carbon and hydrogen. So two choices cannot be same in MCQs. So you're left with methyl methanoate. So for methyl, mass of carbon, which is 12 multiplied by 2 divided by 12 into 2 plus oxygen 16 multiplied by 2 plus hydrogen 1 multiplied by 4. That will be the percentage of carbon in this compound multiplied by 100, because you're finding a percentage. And for ethyl ethanoate, so that will be 1 2 3 4 are there, so 12 multiplied by 4 divided by 12 multiplied by 4 plus oxygen 16 multiplied by 2 plus hydrogen 1 multiplied by 8 into 100. So when you work out, C will be the right answer. Like you have to calculate only for A and C, because B and D cannot be an answer. They have the same number of carbon and hydrogen. An organic compound that react with both lithium tetrahydrodualuminate, means reduction can happen, and magnesium. So for which compound aldehyde can be oxidized to carboxylic, aldehyde can be reduced to alcohol. So it can be aldehyde, carboxylic acid can be reduced back to alcohols, and ketone also can be alcohol. For tertiary alcohol, there's no reaction here, so you're left with A, B, and C. But the second thing is reacting with magnesium. Which of them can react with metal? Basically, the acid can react with metal. That's why B is the right answer. In question 15, the following methods are used to distinguish the pair. Fehling or Benedict solution is used to identify whether aldehyde or ketone. Each compound acid, potassium dichromate is, it will form, it is checked the presence of, it is an oxidizing agent. So if a substance can be oxidized, we can use this. It will change from orange to green. Brady's reagent 2,4-dinitrophenyl is for carbonyl groups for both aldehyde and ketone, and few drops of compound added to water. Basically, it's showing a solubility and a violent reaction will be there if it is ethyl chloride. So which test would distinguish between 2-methyl propane to all? So one is alcohol, it's a tertiary alcohol, and another one is butanol. So we can use 2,4-dinitrophenyl hydrogen because one is a carbonyl group. So this will give a positive result and this will not show any change. For part B, the question is which test would distinguish between propane 2 all and butane 1 all. So basically one can be oxidized, the other tertiary alcohol cannot be oxidized. And butane 1 all is a primary alcohol which can be oxidized, so we can use oxidizing agent which is potassium dichromate 6. A cannot be used here. Why A cannot be? Because A is Fehling or Benedict solution. So Fehling and Benedict solution is used to distinguish between aldehyde and ketone. Here we don't have aldehyde or ketone. One is the tertiary alcohol, another one is primary alcohol. And the last one, which test could not be used to distinguish between 2-methyl propane 2 all and butanol? So which of the tests could not be used to distinguish butanol? So when you add few drops of compound by like adding a water, so what will happen? Alcohols are soluble, so both will dissolve due to hydrogen bond. Here propanol is, sorry, propanol, 2-methyl propane 2 all alcohol and butanol. One is aldehyde, another one is, so what happened? Because of the hydrogen bonds, they are both water soluble, so it does not give any, well, like we cannot distinguish between them. Is it clear? The MCQs. Because aldehyde can be oxidized, secondary alcohol can also be